Welcome and hello. This is a MODSIM exercise, and we are going to be dealing with results, statistics, and scenarios analysis. So after you run a simulation, you have some quick statistics you can view, as well as compare different scenarios. So we're going to be investigating that in this exercise. All right, as with most exercises, we're going to start from the very beginning and start sketching our network. And this is what it's going to look like. I'm going to start with a non-storage node. I'm going to call it NS1. This is going to serve as the inflow to the reservoir. So that's next. I'll click on the reservoir. Boom. I'm going to label that res1 and then move the label off to the side. Downstream of the reservoir, I'm going to have another non-storage node, NS2. And then I'm going to have a consumptive demand node right here. And then finally a sink. For demand, I'll call that D1. Sink, I'll just leave that labeled as it is. I'm going to go ahead and connect my network with the links, just dragging from the upstream node to the downstream node. Once the cursor exhibits its pointy hand icon, there we go. And let me go ahead and save. So file save. Okay, here's the project directory. I'll just leave it at network1.xy. That's fine. Click save. It says network1 up here, so I can move that window around within my main interface. I can minimize it and then make it larger. Let's see, that's maximize. This is mobile. Okay. Next, I'm going to add some data to the network. And what I'm going to do first is actually set the time period. Because if I open up the dialog box here for my inflow, NS1, non-storage node, and I say this varies by year, then from experience, I've had better luck when I set the time series for data first, the extent of the simulation. So I'm going to do that first. I'm going to go up to MODSIM network settings. And then on the time step tab, I'm going to create a 100-year simulation with a 1-month time step. So we'll leave the 1 month right here. Good. And then for data end date, I'm going to click on the year 1980, and I'm going to type in 2080. Okay, I'm going to click off or tab off. Okay. And then in this drop down here for the simulation end date, I'm going to change that to the very last record on this drop down, which is January 1, 1980. Okay, so we have 100 years of data. This table right here will have 1,200 records because that's how many months are in a century. And I think that's all I need to do there for now. I'll click apply and OK. All right, now we can go ahead and open up our NS1 non-storage node. I'm not going to type in 1,200 records here for flow rate. What I've done is prepared an Excel file, which will synthesize the inflow. I'm going to start it off at 29,000 acre feet. That'll be the inflow for the first month. And then after that, I have developed an equation, which basically takes into account the previous month, as well as that monthly average, monthly standard deviation, and some statistical randomness as well. So I'm just going to click off to the side, let it regenerate, and then I'll take this data right here. So I'm copying 1,200 different inflow records. I'm going to paste it over here just so I can paste values. There we go. Now let's go back to our NS1 inflow node, our non-storage node. Right click, paste the column, and oops, I need to do varies by year. I forgot. Okay, let's try that again. Right click, paste column. Okay, so I'm seeing the year show up. I think that looks good. Let me just scroll down towards the bottom. Yes, so the last record is December of the year 2079. That's nice that we have that flexibility in MODSIM to make the years go that far out. Okay, the units here are in acre feet per month. So in this exercise, I'm going to be dealing with storage and volume in acre feet, flow rate in acre feet per month. Click apply and click OK. All right, next one I want to edit is the reservoir, res1. So I'll go right click and open the properties. Make this a little bit skinnier here. Here in the general tab, I'm going to define the maximum volume of 200,000 acre feet. The minimum volume is going to be 50,000 acre feet. And then the initial volume will be 150,000 acre feet. This initial volume of 150,000 is also going to be what I set my target volume at. So we'll get to that in just a moment. The priority here for the reservoir is 100. That's what I'll keep it at. I'll click apply. And then as mentioned before, the targets tab is the only other tab that I'm going to be using for the reservoir in this exercise. And I'm going to set the percent target storage for the basis. And then the volume right here is going to be 150,000 acre feet. I'm going to click apply, click OK. Next downstream is the link between reservoir 1 and NS2, this non-storage node. I'm going to make a couple edits here because I'm going to first convert it as a multi-link. And the two parts of the multi-link will be the main flow, the main conveyance, that is going to have a maximum value to it, a max capacity. And then the other link in the multi-link will be a spill, which will not have a maximum capacity per se, but it will have a cost because I want to minimize that spill. Okay, so I'm going to select the first and only link within the multi-link, which is just, there's always one to start. Click Edit Link, and then what I'm going to do for the name is just do a dash main, and then this will not have any cost, but it will have a max flow rate of 50,000 acre feet per month. Okay, so that's good there. I'll click Apply and OK. Now I want to create a second link in my multi-link, so I'll click Create Link. This is going to be called spill, so I just do a little suffix spill. This will have a cost, and I'll just set it to 1,000, which is a very high cost. And then the maximum value right here is just absurdly large, so effectively no maximum. All right, so I'll click Apply and OK, Apply and OK, and our multi-link is ready to go. What that multi-link is going to do is try to prevent flow from exceeding 50,000 acre feet per month. But if it has to, we're giving the reservoir an option to spill that water just so we don't have some sort of infeasible solution. All right, the next node down is NS2, nothing to do there. The last element that we need to define any data for before running the model is this D1. This is our demand. So I'm going to double click to open that up. On the general tab, I'm going to set the priority to 50, which means it has a lower number priority number than the reservoir one. So the reservoir one does want to deliver the demand to that demand D50. And then for the flow rate on time series, I'm going to just type in a constant 20,000 acre foot per month. Apply and OK. So really what we're looking at here, what's kind of fancy about this model so far is the inflow. As you saw, I generated in Excel, brought it in here. That's going to be the focus of what we look at when looking at statistics and the scenario analysis. So I'm going to click Save and then click on the MODSIM menu and then Run MODSIM. Here's the confirmation. Yes, let's do it. Okay. MODSIM ran. It just took a couple seconds, even though this was 100 years of data. It's a fairly simple network, though. So let's go ahead and see. It says 0.054. Oh, that's in minutes. So a little over 3 seconds, I guess. Now let's go ahead and take a look at some of those results. I'm most interested in the data at the reservoir because that can also capture inflow and release. So right click, and now I'm going to click on Graph. All right, so what we're seeing in this plot is the volume. I expand the storage. Let's see. So this right here is our target. That's constant. And then if I toggle on storage, this is the actual storage. It looks like a couple times here we have near spill. It gets up to 195,000 acre feet a few times, 190, 185. And then it also gets down to 130. So remember the target is 150. That's why the reservoir is trying to stay close to that 150 line. If we zoom in a little bit, we can see a little bit more of the detail on a year-to-year basis. And then just using the right mouse button, I can click and hold it down and use that as a pan, which is especially nice once you're zoomed in. To zoom out, you can just drag left. To zoom in, you drag right, kind of in the southeast direction. So northwest, zoom out, southeast, zoom in. Yeah. If I was curious about one particular year, I can zoom in multiple times and get some of that detail. So I'm going to go ahead and zoom out all the way. And let's take a look at the flows now. So I'm going to change the left axis value to flow. And then let's toggle on. Okay, they're already all toggled on. So the inflow is going to be blue. And then the release is going to be orange, which makes sense because remember we set that maximum of 50,000 acre feet on our reservoir release. I mean, we have the spill option, but we highly penalize the spill. Therefore, that's why we're seeing a maximum of about 50,000 right here. And then the minimum appears to be around 20,000. And that's probably because the downstream demand is 20,000 acre feet. And of course, this plot right here does relate to the previous plot we looked at because if the inflow exceeds the release, then we're going to have an increase of storage, and vice versa would be a decrease in storage. And we want that storage to remain constant at our target of 150,000 acre feet. Okay, so this isn't anything you haven't already seen before in any of the lessons or exercises, but what's new is the statistics and the scenario analysis. So let's talk about statistics here. The inflow is probably best to start with. So if I go right click on this inflow series and click on statistics or just hover over statistics, I get the quick statistics for that data series. We have a maximum value of 82,070. That's in acre feet per month, a minimum of just 5,200. And then we have an average, a sum, a count, standard deviation, and variance values. So yeah, these are in acre feet per month. I suppose variance is in acre feet per month squared. And then that's true for all of the different series. We can look at the same values. So for instance, here is the outflow or the reservoir release. I come down here to statistics. By the way, I'm doing a right click. Left click will select, but it won't actually bring up that context menu. But if I go right click, it brings up the context menu. And then here are the statistics. Looks like there's no spill, so that's good, which kind of makes sense because the maximum reservoir storage did not actually get up to 200,000 acre feet. It was close, like 195, but we don't have actually any spill in this scenario in this 100 years, so that's good. We have a minimum and a maximum, no surprise there. Our average, sum, count, and then variance. Also similar to statistics is a flow duration curve. Let's check out the flow duration curve here for the inflow first. All right, so what we're seeing here is sort of a percent non-exceedance plot. Along the bottom, we have the percent of time that the value was equaled or exceeded. So you could say like only 10% of the time is that inflow greater than, trace this line across, 50,000 acre foot per month. Or you could look at the median and say half of the time the inflow is more and less than, where was I at? Maybe around 25,000 acre foot per month. And then like this, the lowest 90% of or 10% of inflow would be right here, which is at about 18,000 acre foot per month. So this sort of analysis is helpful. This is not something we couldn't have already done in Excel. In fact, the same is true with the statistics. So these numbers here and this flow duration curve showing exceedance probability can be gathered from the data we have in this plot. So we were looking at the plot tab. Here is the data tab. And if I click on plus to expand, here, right here would have the inflow and the outflow. Here's the inflow column right here. And if I scroll over, there's a couple more fields of interest like the storage release. So this is the release. And then this is the downstream flow. So yeah, it's the same thing. Okay, so let me go ahead and close that up and go back to the plot tab up here. Let's take a look at the volume one more time. So here's volume. I need to zoom out. Okay, that's the problem. If I click on storage, I can click on flow duration curve. Boom. Now we have a similar plot, but this is now for the reservoir storage. It looks like we're right at the target of 150,000 acre feet for, you'd have to subtract about 16% of the time from 58% of the time. So was that 42% of the time approximately we're right on the target? And then you could say, well, we're within 5% or 5,000 acre feet of the target, and then trace across from 145, which is 80, subtract 58. So 22% of the time we're between 145 and 150,000 acre feet of storage in the volume in the reservoir. So these plots right here are a really helpful way to just get a quick idea of your system, whether you're looking at the storage in the reservoir or the inflows or the demands, which we're not even really looking at demands for this exercise. But yeah, it also creates a separate tab up here. So now we have three tabs. There's plot, there's data, and then there's duration curve. The last part of this exercise, I want to check out the scenario analysis. So to do that, I'm going to close the results here. I'm going to file and save. Looks like I've already saved. And then what I'm going to do is bring up the project directory. And what we have is our network1.xy file with the output. I'm going to just create a copy of that file right now. So I'm going to hold down Control, just drag a new file. And then I'm going to rename this to network2. Oops, network2.xy. Everything else is the same. I'm going to go ahead and open up that cloned file now in MODSIM. So open. And then here's network 2. All right, looks the same. I shouldn't have any results for it yet. Yeah, I can only click on properties. There's no graph option in this context menu when I go right click, and that's fine. And what I want to do for this, we'll call this scenario 2 or network 2. I'm going to modify the inflow data. All right, so let's open up the Excel. And what I'm going to do is basically decrease the average monthly flow by 5,000 acre foot per month. So I'm just going to copy in my network 2 average values here and then paste them in. Okay, so let's generate a new time series inflow. It looks like it's been generated. All right, so let's go ahead and copy that data. I'm going to paste it in over here just for safekeeping in case I need it for something else. So boom, it's still on my clipboard though. So I'm going to come over here, open up the properties for this non-storage node 1, and then instead of starting with 2,900 acre foot for the first month, I'm going to right click and paste the new values in, paste column. Now we're starting at 24,000 acre foot per month. And then this time series here is based on just a lower average. All the other parameters like standard deviation and the randomness of the time series, I didn't change that. I just need a little bit different data to look at and compare. All right, so I'm going to click apply, click OK. Everything else in my model, I'm just going to leave as it is. Remember, the demand here is still 20,000 acre foot per month. It's a constant. The reservoir has the same storage volume, minimum, maximum, target, and priority. So I'm going to go ahead and save and then go up to MODSIM, run MODSIM. Am I sure? Absolutely. That ran. Looks like we're good. Let's go ahead and take a look at the results now. So I have network 2 maximized in the window, but I wanted to just not maximize it and just let you know that I still have network 1 open right here. So it didn't go anywhere. I just have network 1 and network 2 sharing the same window. That's fine. That's allowed. And to enable the scenario analysis, you want to go up to the MODSIM menu and then click on Scenario Analysis. And then I get this important to note message, and I'm going to read the whole thing here. It says, after selecting the scenario analysis option, every network loaded in the interface will be considered when you select a node and or a link to graph. Okay, so you'll see what that means. Because if I go back up to MODSIM menu, you see scenario analysis is checked. So I don't want to change that. That's good. I'm going to go right click on the reservoir and we're going to click on graph. All right. Now what we have is network 1 flows, network 1 storage, network 2 flows, network 2 storage. Now right now we're looking at the volume. So that would be for both network 1 and network 2. In fact, down here in the plot, we have the labels. I'm going to toggle off the targets because that made it a little bit busy. Okay, here we go. Orange and blue. Blue is network 1. Orange is network 2. As you can just tell from looking at all 100 years here, network 1 has seemingly higher volumes, which makes sense because when we generated that time series inflow, it had 5,000 acre foot more on average. And then the orange, you see a little bit more orange below the blue. This line right here is understandably the target of 150,000 acre feet. Let's go ahead and zoom in a little bit. Yep, so when we zoom in, we can see, generally speaking, the blue line, that storage is higher than the orange line. Now, there will be some exceptions over the course of 100 years. There's a serious dip in storage right here for the orange line. That's our network 2, and some serious peaks right here for the blue line. That's over 190,000 acre feet right there, but no spill. I didn't correlate these numbers the same, meaning the random variables were not synced up between the two different networks. There's a lot of different things I could have done here. Oh, looks like network 2's got a few high storage volumes here. Oh, network 2 may have actually spilled. Interesting. So just like looking at the plots and comparing the two networks using the scenario analysis, we can also do the same thing when we click on the flow duration curves. All right, so this is the flow duration curve for storage for network 2, and we've already seen network 1, but I'm going to bring it up onto the screen here. We can now compare them next to each other and glean some of the similar results, but it may be even a little bit more meaningful when we see those two different networks compared against each other. This is really powerful because you can modify and change certain input values to your model and then bring it to screen and take a look at the results by comparing those models in real time with just a few clicks. If you had a lot of different networks all loaded in at once, you do have controls down here to toggle on and off the networks. So I'm just toggling them off and on right now to demonstrate, but 2 is not too busy. Let me go ahead and show the same thing when we look at the flow. Okay, I had to reopen the graph, but let's take a look at the inflow from network 1, flow duration curve, and then the inflow from network 2, flow duration curve. All right, pretty much as we expected, how the network 1 has slightly larger flows, and then the exceedance probability along the horizontal axis is just as it was before. All right, well, that's all I had for this exercise. We had two different networks in our MODSIM, and we talked about the results, statistics, and scenario analysis.